Hello everyone. So today we are going to solve LeetCode today's problem of the day, which is 3381 maximum subarray sum with length divisible by k. So with the problem we understand that we have to find the subarray of length k. Okay, length note, that means subarray of length which length that length should be divisible by k. Like suppose if here the length should be 1 of subarray and we have to find the maximum separation, that means length is 1, that means this is possible or either this is possible. Okay, so this is for length 1. Okay, now if we take complete, then this become length 2 and that length 2 is divisible by 1. So this is on the total sum would be 3 and this is the maximum value. Take one more example, k is 4. That means our length of the subarray can be 4, 8, 12, something like that, but 5 is there, so only 4 1, like we can take either this 4 or this 4. Okay, these two are possible and we know this is the current answer. 4 3 7 2 9 1 10, that is minus 10. Okay, if we take this one, so we can take either 2 or 4, something like. So if we see like either we can take the array of that means sub array of 4 length or 2 length. 6 is not available, so okay. Now if we talk about the, okay, so now, okay, so what are the things that should come in our mind? Okay, if we think about the brute force, what will we do? Okay, we will move from here. Okay, and going to add like minus 5 plus 1 plus 1, that means this is minus 4. Okay, divisible by 2, so we will make our answer for now is minus 4. Now we again move. Now this become minus 2, but this is not divisible by 2, so we will move. So what this become? Minus 8 plus 3, that is minus 5. Okay, but this length is divisible by 2, so okay, but we already have a minus 4, that is a bigger number, so we'll leave this. Okay, and this become length 5 of no of work. Now we will start with this. Okay, and we will check like what is this sum, what is like then this sum, and we are going to find the max. So if we talk about its complexity, so actually we are iterating one loop for complete and in next also, so n into n. But if someone smartly say like okay, if we make a prefix some array, then we can jump from here to suppose if I is here, then we our as I need the length of k, so we will move by k step. That is also, in that sense also, our total would be like size in n into n by k. So if we see the constraint, then this constant is this one. So if the k is 1, then this one into this one, 10 to the power 10 by 1, so which will not be passed. So now I'm going to see the optimal solution. Okay, for optimal solution I have a page. With the help of one, I am going to explain. So if this one is not the page. Okay, 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 so this one is the page. Okay, now suppose, okay, this one, this 0 1 2 3 4 5 7 8 9 10, this is the indexes. Okay, now we are going to find the sum. Okay, so we are going to make a n variable or a prefix array which is going to give you the sum till this one. Like if we are here to sum up to index 1, sum up to index 2, sum up to index 3, sum up to index 4, the sum. Okay, now if now what is like our main purpose is like that sub array's length should be divisible by k, right? So either that sub array length should be 7. So now and k is supposed 3, so 7 modulus 3 is 1. So if 1 is divisible by 3 or not, so that means I want to say like instead of that index, we can make that index smaller to k. That means like k is 3, so that will be 0 1 and 2. Okay, now so what we are going to do, first we are going to find the prefix sum for each index, right? After that, suppose if any index is I, okay, so we are going to make that I modulus k, and whatever the I modulus k will be 0, we are going to store in 1. Like similarly, whatever the I modulus k whose remainder is 1 we are going to save here. Okay, similarly here, so if we see like whatever the remainder, what are the thing that is going to give you the remainder 0 for k equal to 3, that is 0 3 6 9 12. Similarly if we remainder 1 is 1 4, so if we see the difference, 3 minus 0 is 3, 6 minus 3 is 3, 9 minus 6 is 3, so each one length is 3. If we take 0 and 6 also, then 6 minus 0 is 6. If we take 3 and 9 also, then 9 minus 3 is 6, or 0 and 9 also, so each one is divisible by 3. Okay, that means each length is divisible by 3. Similarly, in this section, if you take any two like 10 and 1, that is 9 divisible by 3, 7 and 1, 6 divisible by 3. Similarly this one. So if the remainder is same, that means that remainder is going to cancel and that should be divisible by k. Okay, now what next? So before going to next, I want to implement till now, then we are going to do. So what I said, okay, we will make a prefix array of size n, and we have initialized with 0. And what this n is, and this n is nums dot size. Okay, right? Okay, now for loop int I equal to 1, I less than n, I plus plus our prefix. Okay, after prefix of I equal to nums of I plus that previous value, prefix of I minus 1, right? Okay, now what next? Now for that we need the value of prefix of 0 equal to nums of 0, right? Now okay, now what we want actually, like we need a loop and we want a vec. Okay, so where like for remainder 0 what are the value, for remainder 1 what are the things. So we are going to make a vector of long. Okay, let's take its name container. Okay, and its size will be key like 0 to k minus 1. Okay, okay, now container of this become container of I modulus k. Okay, okay, dot push back whatever the index of I is, that means whatever the value at till I is there, we are going to put in this one. Okay, so instead of this loop we can, as we have the this I at this position itself, so we do not need to make another loop, we can write here itself and this one. Okay, so this is our vector. Okay, this is of no use. So what I did till now, we have just make a, okay, let's see. Okay, so we have make a container and one prefix is there. Okay, so now what the prefix of I is like nums of I plus I minus 1, and for initially we have declared this with, and we have a container like for remainder 0 what are the things is there, for remainder 1 what are the things is there. Okay, so till now we have coded. Now what the next thing is, suppose now what our work is. Now when we are, suppose when the remainder is 0, that means 0 3 6 9. Okay, 0 3 6 and 9 is there, what can be our answer? So first we go from this one to this one, so that then our sum would be like here 0 3 6 9 is there, and sum is 0 6 21 45. So when we are from 0, okay, so when we move from 0 to 6. Okay, so what are the meaning? Okay, let's start with 0. So when we are 0, okay, so where our answer is max of answer, which initially the answer is minus infinity, so answer comma, okay, 0 minus, and we have to also, that means remove. So actually what we want to remove least number, so that if we remove least, so we get the maximum number. So like, okay, so initially we are making it like infinity, so 0 minus infinity, okay, something, so automatically answer is our answer, that is 0 itself. And we are also going to remove this variable is remove mean. So this one we also want to make this one as smaller as possible. So this is 0 and initially is what infinity, so we make it 0. Now when we come at 3, okay, at 3, then sum is 0 and minimum is 0. So 6 minus 0, our answer is 0. When we come here, our minimum till now is still in 0 and 3, still our minimum is 0. So this become 21 minus 0, then 45 minus 0, answer is 45. Now when we talk about this one, so in this, like from here, okay, minimum is 0, here 0, here 21 minus 21, so this one is minus 21, okay, and this one, okay, 45. So from up to here, the 45 is there, 45 minus 21 is there. If there is another answer also possible, we can say, like, why wait, what are the things that I want to say. Like suppose if we move here, either this can be our answer, okay. Now if we move up to here, that means up to 6, what are the answer? Either 0 to 6 would be answer, or 3 to 6 is, or 0 to 3. So when we move from 0 to 3, this section already covered. Now when we move from 0 to 6, okay, now what can we answer? Like 0 to 6 minus 0 to 3, this section we can remove. And how it would be removed? It would be removed if this section is the minimum. Okay, now now if suppose this one is up to here, so that what can be the answer? So either this point would be minimum, or this one. If this one is minimum, so our answer would be like this section, okay. If this one is the minimum, okay, so then our answer would be this section. If this one is minimum, means that the sum from 0 to this one is minimum, okay. So now, okay, now we are going to code this same, okay. So for loop int I equal to 0, I less than k, I plus plus, that means container, I'm talking about the containers, okay. So now another loop for, okay, long what we can say this one is as a current sum, okay. Now this current sum will come from container, okay, sorry, container of I, okay. Now what our task is, our things is like two things. One is remove, okay, okay. So what like means, one is like we have to update our answer. So what our answer is for, like long answer, as we have to return maximum, so we will declare with minimum. So long minimum, okay. Now, okay, right now, one value we want to remove, that means we want to remove a section which is and that means if we want to increase our answer, so we have to we have to decrease this from a list value, we need to decrease it. So we can name that as long mean, okay. Long okay. I'm just taking name it as a remove. So this become for now, let make it long ll max, okay, right. Now now what are the things, like now I have answer, and we want to make that answer maximum. So answer equal to max of answer, comma. Now we have sum, that means this, okay, this is what we have named it, this current sum. So we have this current sum, that is current sum is 0 to that sum. So current sum minus that minimum value which I need to remove, okay. Now we need to update this one also. Whenever we get a smaller value, we are going to, okay, make that means remove equal to min of remove, comma, this current sum, okay. Now one issue is there, as this remove is, okay, max, that means long max. So if suppose current sum is initially like in this case, if this one is -1, so -1 minus long, this will be out of bound. So we will just need use a check, like if this one, if remove, okay, not equal to ll max, then we are going to do this, okay. and other. Okay, and we are updating this remove also. So now if we run, still it is wrong. What is wrong? I am going to show. First I will run. Mm, okay, this is not ll, that means long. Anywhere much, this is long. Okay, now we have to return that answer. It is still wrong, but I am going to show you what is the issue by showing return answer. Overflow from where, like heap overflow on this one. Okay, current sum from container of I. Okay, this condition, I think. Remain serializing this one in out of range, in which line? So let me see. Okay. So in this 1 comma 2, it's skipping. Okay, we have not set our container for 0 equal to nums of 0. Okay, because the first index is also going to um put, that is this one, this container is equal, because we have directly started with this one. So now they are saying like container is not defined. Okay, but this is no viable overload container of 0 equal to nums of 0. Okay, sorry, container of 0 dot pushback, right? Okay. Yeah, now what is the issue that I want to show you? I was knowing that one issue is there. The issue is, like if you talk about our bucket, suppose we take an example like this one, 1 2 is there. So what this thing is doing? Okay, so like at first, okay, this sum takes sum is 1. Okay, like here. Okay, come here. Okay, so whatever the things is there, initially that for remainder equal to 0, but this come first 1 will come. Okay, so 1 will come, this one is still max, so this will do nothing. Okay, and our this remove would be 1, but remove would be 1 now, because 1 is the minimum till here. Now if next, if 1 2 is there. Okay, if 1 and 2 is there, so what now? So if 1 2 is there, then it will again come. But what the answer is, this one is current sum minus remove, that means 2 minus 1. That means this is removing a section, so this will always remove a section. Okay, so from it will take total value minus a minimum, whether that is a positive or negative, it doesn't matter, that is going to remove. So that is issue. What it mean? It simply mean they are not considering the thing just before the index 0. So like prefix of -1, which is going to say like this we need to reduce. So we have to just add a edge case. Okay, what that is? Okay, so okay, now we are going going through the loop. Okay, now if okay, if I plus 1, which is length, this one modulus k equal to 0, that means this is currently divisible by k. Okay, so we are going to write answer equal to max of answer comma prefix of I, which is the sum. Okay, now if we check, okay, now okay, using this, okay, if you don't want to use this, we can also optimize this. Okay, so here we will loop this condition, but okay, so we will remove this and we will make this one. Okay, here to make to come here. Okay, so this become our answer. Now one thing just we need to add, like actually we from here I equal to 1 is this, so for I0, okay, for I0 we need the same condition like whatever this one, because we have started from here from 1. Okay, so this one is there, so I0, that means this total become 1. Okay, what this become, this become 1. 1 modulus k equal to 0 is simply, okay, either you can also write this, so answer is equal to this one, prefix of 0. Now if we run, okay, so if we submit, okay, now if we talk about the complexity, okay, so here I have taken an array, okay, output prefix which is of big of n, and a container that means of k, and this is going to contain this means long. So if okay, this k into whatever the, what you can see the average. Okay, so let me say this is a 2D array which has the k row, and this would be like variable. Okay, like in some if you talk about a generic value, then we know that total we have, what we have the total value, so total value is n. Okay, and if we divide by k, that means n by k, so we can take an average of n by k, so n by k into k. Okay, this would be array. Now these two arrays there. Now if you talk about the time complexity, so okay, this one is for big O of n, and this one is for big O of n. So big O of 2n is the time complexity. Oh, no, sorry, this one is for big O of n, and this one is for k into. Now again we are going inside that container. So what that container actually contain, in, if we see from above, then that container is currently some remainder some indexes, another remainder some indexes. If we add the all the indexes in each remainder, then that is equal to, that is equal to n. Okay, so this is also n, so big O of 2n for the time complexity. Okay, thanks for watching.